Should be recording now. It is recording now,
I
and
think
it's also sharing my screen, so which is perfect. So to summarize, we have a tie between choosing between a single meeting and rotating the meetings. In this case, instead of asking for a tiebreaker, we'll interpret this result as a preference to keep the meeting schedule as it is today, therefore with a single meeting. But we have a preference for a different time zone, which is 4 in the morning GMT, which translates to 9 p.m. Pacific, daylight saving time, 11 p.m. Central, 6 in the morning European time, and 12 p.m. China time. We will now start meeting at this time. We will communicate, we share this with the community over the email channels. I think we need also to update the some pages in the code repository. And the next meeting, therefore, will be in 2 weeks' time on Monday, April 20th at 9 p.m. Pacific, or Tuesday, April 21st, 4 a.m. GMT. That's right, because by the way, we had a tie between the choosing the day, and according to contributor preference and the KTS Kubernetes contributor calendar, it seems like Monday is the best day, and therefore we will go for Monday. And with that, we can conclude the discussion on the meeting time. So in the mean, yeah,
can you
go ahead.
do the action item of updating the meeting time and the README for Antrea?
Yes, I can do that. I need to write it down, otherwise I'll forget it. Let me write it down for myself.
I assume
Okay,
the link
cool.
for the meeting is going to stay the same. I don't remember how Zoom works, but
Sorry, the meeting ID, I don't know if it's going to be the same, I never updated the meeting on Zoom, but I think we don't have to change the meeting ID.
and you may want to. I think you can update the meeting settings, by the way, to toggle like auto recording. I'm not sure, but I think
that is right. Yes, that's right. I think I think I can toggle it. Yes. Okay. So now should we proceed to discussing having a look at the release status, even though we know this is one of the most boring things we can do in our meeting. So if there is any other one who wishes to propose a more exciting topic for today, please step forward. Otherwise, I will annoy you with the release.
well, I'm happy to talk about the agenda item I had for last meeting, which we didn't have time to cover. Which
Oh,
is
that's right.
yeah, a DD log implementation for network policy computation.
Go ahead.
Is everyone okay with me covering this?
Absolutely.
All right, let me share my screen. Where is we go? All right, hopefully this is working because my camera is not working, but I hope screen sharing is working.
Works.
Perfect, thank you. So this, like, I'm going to try to keep it short, but basically the topic of this conversation, of this presentation, is how we may be able to use DDLog, which is like a computation engine, as an alternative implementation for the Antrea network policy controller. And so I worked on this with Leonid Rizik from VMware, who's been like helping other projects inside of VMware transition to DDLog for their computations. And I ran like a bunch of benchmarks, and I'm going to present the result at the end and try to like kind of like maybe draw a conclusion about whether this is something we want to investigate further or not. So today, Antrea controller receives inputs from the Kubernetes API server. So we watch for namespaces, pods, network policy updates, and we produce internal outputs that we send to the Antrea agent. And those objects are called applied to groups, address groups, and internal network policies. Applied to groups is basically an IP address set of pods on which a specific policy is being applied. Address group is a list, also an IP addresses, but it represents like the peers for the network policy. So the peers on which we apply the ingress rule or the egress rule. An internal network policy is just like kind of like an internal representation of a Kubernetes network policy, which instead of using labels is using references to apply to groups and address groups. And each output object has like what we call a span, which determines a set of agents or nodes which need to receive the output. So we only send information to agents when this information is required by the agent. And the implementation of the network policy computation can be divided into two steps. First, we compute these output objects applied to groups, address groups, internal network policies, and we publish them to a store. And then we have watchers for that store, and incremental updates to the store are distributed to the appropriate agents based on the span through an internal API server that we have. And instead of distributing the whole object all the time, we have like incremental distribution. So not only do we only distribute the information to the relevant nodes for each update, we also only distribute the incremental update. So for example, IP addresses being added to an apply to group and not the entire apply to group every time. And so the idea behind this investigation is, can we use ddlog for the first step, computing output objects and publishing them to the store? I have a slide here that I worked on a while back, which shows how network policy computation works in practice in Antrea. I don't think I'm really going to cover it in detail, but if you're not familiar with the implementation, you may want to look at that slide. Basically, it shows starting from a simple Kubernetes network policy, which has pods with label app is equal to server can only receive traffic from pods with label app is equal to client, and only on port 80. What are the internal objects for a specific cluster that we're going to generate, and how we're going to distribute them to the different agents. So you have that box on the right side here that shows the apply to group, which is computed. It's just one IP address, the address group, and the internal network policy, which refers to that apply to group and that address group. So now what I imagine people aren't familiar with is, what is ddlog? So ddlog stands for differential data log. It's a project developed at VMware Research by Leonid Rezik and Mihai Budiu. And I added two links here, one to the GitHub and one to a paper that presents ddlog in details. And so if we look at this paper and we see that basically ddlog is a bottom-up computation engine. So it starts from a set of ground facts, which we call the inputs. So in our case, it's really like the Kubernetes object, namespaces, network policies, pods, and it computes all the possible derived facts, which we call outputs, by following data log rules. So basically those data log rules are like kind of like transformation rules, like joins and everything, which constitute the ddlog program. So the ddlog program is a set of data log rules, which tells ddlog how to transform inputs into outputs. And this is done in a bottom-up fashion. By that, they mean that they always compute all the possible derived outputs ahead of time, as opposed to a top-down approach, which would be, I have a set of inputs, but I don't pre-compute anything. Instead, I wait for queries. Is this thing possible? And I'm gonna like basically use a top-down approach to verify whether this query is true or false based on the inputs that I have. So instead of computing everything ahead of time, I'm going to compute in reaction to user queries. And ddlog is incremental by nature. So whenever it's presented to a change to the input, so ground facts, ddlog is only going to perform the minimum computation necessary to update all the outputs, all the derived facts. In our case, the outputs or the internal objects that Antrea use. And I think maybe this is all a bit abstract. So I included like an example of a ddlog program where we have like one input relation, which is each input is like an edge between two nodes in a graph. Actually, we have a second input relation, which is just the name of a node. And we're going to try to compute output relations, which is the set of existing paths in a graph. So basically, I give you nodes. I give you edges between nodes. I give you nodes that I want to exclude from paths. And then ddlog is going to compute the set of all existing paths, which pairs of nodes can reach each other by using the edges I've provided and by excluding the nodes I've provided from the path. And here, this is an example of this program being used. I insert two edges. I say there is an edge between N1 and N2. There is an edge between N2 and N3. And based on that, ddlog is immediately going to compute three paths for me between N1 and N3, N1 and N2. Those are, sorry, let me phrase it this way. Between N1 and N2 and N2 and N3, those are the two edges I've provided. So of course, an edge is also a path. And then I have a path between N1 and N3, which is just combining those two edges. Now, if I add an extra relation, which says I want to exclude N2 from all paths, ddlog is immediately gonna generate an output, which is just gonna delete one of the paths that I previously had, the path that was using N2 as an intermediate node, which is path N1, 2, and 3, because this path was using two edges, N1, N2, N2, and 3, and one was therefore using N2 as an intermediate node. So this is the work Leonid and I did to have our experimental implementation of ddlog, using ddlog in the Antrea controller. So I wrote some Go bindings for ddlog because ddlog only had a Java and C API, and those bindings are hosted on the ddlog repo now. Leonid wrote the ddlog Antrea controller program in ddlog, and I added the link here. It's also hosted in the ddlog repo for now, and it's used as a test for the ddlog CI. Then I took both of those things and I worked on ddlog integration directly in the Antrea code base and on writing some benchmarks as a starting point, because that was Leonid's starting point for his ddlog implementation. I use Antrea 0.3, which means that there is no named port support at that stage. But that's definitely something that's, definitely something that's easy to add if we want to commit to ddlog. And the first thing I did is verify that the ddlog implementation was passing all Kubernetes community tests. So of course, excluding the named port test because there is no support yet. I also added the ability to run both controllers at the same time and diff the stores kind of like in real time, which is a good way to verify that the two implementations behave the same with more granularity than just with the tests. And here are the different benchmarks I ran to evaluate the implementation. So I wrote 5 tests, and not all of them actually may be representative of how an actual cluster is going to be used and what actual Kubernetes network policies are going to look like. But I kind of like wanted to exercise a bunch of like different edge cases as well. So and if you guys have ideas on what kind of other benchmark I can perform, I am happy to add a test for that. So the first test, well, I'm not going to go into too many details, but the first test basically is pretty basic, and that was the first synthetic benchmark I had. I had one network policy per pod, each one with one ingress role, and I had like 10,000 pods all in the same namespace. So that's why I say it may not be like a realistic test. If you're familiar with the work that we've been doing in the Antrea network policy controller, you'll see that testperf3 is actually the one that Chan has been using as the latest benchmark that he added to evaluate the network policy computation code. So testperf3 is the actual benchmark we have in the Antrea code. I just ported it and was able to run it for the ddlog implementation as well. Testperf4 is like kind of like a different version of testperf3 where you have like kind of like more objects per namespace, because Quant's test only has like 4 pods per namespace. I don't know if this was like a very realistic use case. So testperf4 is kind of like the same idea, but uses 50 pods per namespace instead. And testperf5 I added recently, and instead of using pod selectors for network policy, it uses like namespace selectors for from and to network policy role peers. So I thought that was an interesting test to add. So feel free to look at the test, feel free to look at this slide, but I'm going to jump directly to the results here.
Tony, a question here. For all these tests, it's like you are simulating the input to ddlog, or you usually have a correct cluster?
There is an API server, but there is no cluster. It uses exactly what I've been using as well for a while. Uses what Chan is using in his test, which is like what they call the fake API server, and it's only testing like computing objects and publishing them to the store. It's not taking into account like distributing the policies to agents.
Okay, got it.
And that's actually like a good point, because, well, I'm going to walk through those results, but you see that for some tests, the time it takes to compute the policy, even though we have large inputs, is kind of like small. So if the actual time is like dominated by network policy distribution, if the CPU usage is dominated by the distribution to agent, then the differences in time between the ddlog and the current implementation may be neglectable. But so this table shows what I call the computation time, which is the time it takes for the implementation to take all the inputs and generate all the outputs in the store. And so we start the clock once we've published all the objects to the API server, and before the Antrea controller starts watching the API server, and we stop the clock once all the updates have been published to the store. The total CPU time kind of like measures the impact that computation has on CPU consumption. It's not very accurate, but it gives a good idea of which implementation is more like CPU hungry, more resource hungry. And then the peak memory, well, that's pretty easy. We just measure the maximum memory usage while the test is running. And so you see that for testperf3, which is a test case that Chan recently optimized as a network policy controller implementation for, the current implementation behaves like is very efficient and is actually better than the ddlog implementation. For testperf4, which is kind of like a similar test, the difference is not as big. And actually the current implementation uses more CPU resources because there is increased parallelism. It can achieve like better computation time. And if we look at the other, mostly testperf1 and 5, which may be like really like synthetic benchmarks. I don't know how realistic they are. At least testperf1 is kind of like synthetic. I think testperf5 kind of like is like a realistic use case probably. You see that there is a huge difference, like kind of like a for testperf1 it's like a 150x difference. For testperf5 it's like a 30x difference between the DD-log computation time and the current computation time. So overall, what we can take from this table is that maybe for the most common case, let's say test per 4, DD-log is slightly less efficient than the native implementation, the current implementation. But it seems that the DD-log implementation is more like consistent. And again, I think that's because, yeah, go ahead.
Sure. I just wonder if we can look at this test perf1 and the perf5 again to understand why it's so different.
Yeah, I had the same feeling, like why there are why test, for instance, in the native computation time, why test perf1 is like 25 times slower than test perf4.
Yeah, I have a, okay, let me jump to the next slide here. Well, but before I do that, I'll just add one more thing, which is that the memory is always, DD-log pretty much always uses a bit more memory. And in the worst case, that's 65% more memory. So the worst test here. Yep.
Antony, just for refreshing my memory, could you go back to one slide? I want to take a look at the test perf1 and perf5.
Yeah, and I'll share the slides after the meeting.
Okay, 10 tables.
So the number of namespaces, it's
yeah, and I mean, so before, if I go back here, are you done, Jenjun, or do you want me to stay on the
Yeah,
slide?
I'm done.
Okay. So here I added a link to a recent PR that Chen made to improve the current implementation. And without this PR, test perf3 was taking about 20 minutes instead of 4 seconds.
20 minutes, really? Okay.
So what happens is, what this PR does is it's adding like a very specific index so that applied to groups and address groups can be easily partitioned between namespaces. So if you're looking at, if there is an update in a namespace, you can restrict the update of internal objects to the objects for that namespace. So basically what Chen added is he added an index with the key being the namespace, which means that when you have very few objects per namespace, we observed a massive performance improvement, and especially in test perf3, which only has like 4 pods per namespace, very few objects per namespace. By adding an index and avoiding like a linear search over all the objects, instead restricting it to like a linear operation over the object in a certain namespace, we had like performance improvement because you're going from n square complexity to n complexity for very large inputs, basically. And so there was a very significant difference. Yeah, so this slide kind of like is about this and explains all the differences, tries to explain the differences between the different results. Oh, why does it say DD-log here? It's native controller, yeah. So even though the native controller, the current controller is incremental, it's not completely incremental. We still update entire address groups. Basically, we have the notion of sync on address groups and apply to groups, and we recompute the entire object whenever we think this object may be impacted by a new pod or a new namespace, or sorry, not a new namespace, let's say a new pod. Whereas DD-log builds like comprehensive indexes, including indexes not limited by just namespace, but indexes by label. So everything is pretty much indexed, which explains the increased memory usage, but means that we have more consistent performance across all use cases because we didn't try to optimize for a single case. In that case, test perf3, which is the one I showed you before, where we just have indexes by namespace. So if you try to do if you try to work on different inputs where you have more objects per namespaces, and if you try to have like more complexity with different labels that you're using, you start seeing the difference in results. The native controllers still have some functions which are linear in nature. Basically, we iterate over a large set of input, and do label matching, whereas in ddlog pretty much everything is indexed, so the amount of linear search we do is actually pretty limited. And actually, I'll go back here to test per 5. You can see that the result was like 35 seconds versus 1 second. And actually, surprisingly enough, the memory usage was the same between ddlog and the native implementation here. What the current implementation tries to do is every time a new pod is added, we iterate over all address groups object that we have in all namespaces, and we try to do label matching. And this is because all the network policy rules are using a namespace selector, and the index we have for namespaces is useless. We actually have to iterate over all namespaces and check if they satisfy the selector. In that case, we cannot use our index based on the namespace name. Whereas in this case, yeah, sorry, yeah, in this case, index on the labels. Also, ddlog does not recompute the entire address group and apply to group every time. So that's why I said that the current controller is not really completely incremental. It's partially incremental. We don't recompute everything every time there is an update, and it's incremental in its distribution, but it's not completely incremental. However, where the native controller has an advantage is that we actually try to reduce the number of things we do on address groups and apply to groups by using a Kubernetes work queue. So basically, if you have multiple pod updates in a row, if those updates are close enough, we're only gonna do a sync on the relevant address groups and apply to group once. And basically, kind of like the slower the consumer is, which is the internal computation engine in this case, the better this is, because this means that we're going to avoid like recomputing and recomputing. If we get 3 pod updates at the same time, we're only going to update the address groups and apply the address group and apply to group 1. However, this may benefit the network policy computation only, and not like regular updates that comes through the controller lifetime. And why do I say that? Because when we do, all of this is measured using what we call the initial computation. So we load all the inputs in the API server, then we start the controller, which is going to process all those inputs. However, in real life, that's only going to happen once we start the controller, and you may have updates during the controller lifetime, for which we're going to have to update our internal objects. In this case, obviously, the controller is not going to like use 100% of the CPU, but the advantage of using ddlog is more that maybe the CPU footprint is going to be reduced. We're not going to use as many resources as a native implementation. And finally, I've made consistent 20 or 30% overhead just because of how ddlog as a C API, and we need to invoke it from Go. And because we have so many API calls, we have actually a big overhead caused by switching from Go to C. And we believe that can be eliminated by changing how data is passed between ddlog and Antrea. So that's kind of like a significant effort. So that kind of like requires a commitment to ddlog before we can commit to those things.
So Antonio, you have a theory for perf5. Do you have also have a theory for perf1 now? Why is there even bigger gap between native and ddlog?
I think it's, let me refresh my memory here. Yes, it's because everything is in the same namespace in that case.
I see, got it.
I also have the explanation for test perf2, where we also have a single big namespace, but in that case, the native implementation is basically the same performance as a ddlog computation. And that's explained by this line here, the fact that ddlog process each, because in that case, we have only 2 network policies. And so we have one big applied, we have 2 applied to groups and 2 address groups. And that's exactly why I added this test actually, to compute the to evaluate the impact of the work queue. Because in that case, DDLog is going to keep doing updates on the apply to groups and the address groups, and the performance is good, but what the native controller is going to do is going to update those apply to groups and address groups much fewer times than DDLog is.
Got it.
And yeah, once again, that's because basically all the pods are in the same apply to group. So this slide is the open question, but I mean, the question we kind of need an answer to. I mean, it was fun for me to evaluate DDLog, but and we can do more. We can like improve data passing, for example, but that kind of like implies a commitment to DDLog because that's more engineering resources. And I think the big question is there enough upside to switching to DDLog? We saw some big differences, but maybe those big differences can be improved in the native implementation without making the code too complex and without increasing memory usage too much. Maybe those big differences are for benchmarks test cases, which are not actually representative of the real world, in which case are kind of like not meaningless, but they're not as meaningful as the other tests. Yeah, if policy computation is actually not what's dominating CPU usage, but distribution is dominating CPU usage, and then maybe having a little bit of difference is not like very significant. I doubt that distribution account for like 372 seconds, like in this case. So in this case, like maybe the difference between DDLog and the native controller means something. For test per 4, where we have 22 seconds versus 14 seconds, if distribution itself is like 2 minutes, then that difference is not really significant. However, the memory usage difference may be significant.
As we add additional attributes by which we make policy decisions, is it going to be easier to keep the translation from those attributes into the DDLog form, right? It's basically where we wouldn't have to continually update the computation engine, right? We're just basically transforming attributes into the DDLog form. Is that going to be easier to maintain long term and basically continually updating our calculation engine?
It's pretty easy. It's just in a different language. So you update that program and then you recompile it. I think what you bring up is a very good point, because here what I have is so right now the DDLog is a bit smaller itself, but we have a lot of like dumb conversion code between DDLog inputs, outputs, and Antrea output. And I think in all fairness, I mean, I'm not trying to be biased here, but the current controller code is like not very complex. So at this stage, maybe there isn't enough upside to switching to DDLog. But actually, as we add more complexity to our network policy, for example, if we have like our own Antrea global network policy or cluster network policy object, then having something that like DDLog may start to make more sense, if that means that those new objects are actually going to drastically increase the complexity of our Golang controller implementation. So that's something to keep in mind. If we can keep the complexity small and stay incremental, or try to be more incremental even in our current controller, then maybe switching doesn't make sense. However, if the introduction of new inputs makes our controller more complex for some reason, because we have more different objects to handle and we don't have like common representation at some point in the API, then it may make sense to switch to DDLog from that perspective. I'm not.
That's what I was getting. That's what I was getting at. Basically, the translation to DDLog primitives might be simpler than maintaining a native computation.
Yeah, I think just as Tony said, I believe the major benefits of DDLog is not about performance, but it's more about the simplicity in code.
Correct.
So if you really have lots of complex logic, then probably it makes more sense.
Yeah, I think the consistent performance that we get is also a plus for DDLog, but there is, I think the point of this investigation, and we did a lot of work with Leonid on this, is to show that from a computation perspective, DDLog is not going to be worse than the current implementation. And we knew that memory would be increased because you're bringing that additional like C library with its own like internal state. So the point was also to evaluate that the memory usage wasn't going to go through the roof.
I'm also
what
curious.
I mean that
Go
if
ahead,
you
Jinjin,
spend
I'm sorry.
time, you can okay, very quick one. I mean, if you spend time, you can always optimize your Golang code or C code, whatever code, to be as efficient as ddlog, I guess, maybe more efficient. But just like sometimes it's a very complicated problem to really write good code, right?
Yes, yeah, we can try to like improve how we handle like that fifth case, for example, in our current implementation. That may make the code like more difficult. Whereas in ddlog, it's like, I mean, in ddlog, it's very easy to build index indexes. It's also not very complicated in Kubernetes, right? Because we have all those like Kubernetes libraries. We use all the Kubernetes primitives, and it's actually pretty easy to also build indexes in the native Golang implementation. If you look at Quan's change to optimize test-per-3, you'll see that building the indexes is actually just him adding a couple lines of code. I mean, the diff is very small because we have all those powerful Kubernetes libraries that we can rely on. But
I guess another thing that
nice
I'm not sure it's a advantage of Golang or other language. I mean, probably you have more control on what you want to optimize. Of course, sometimes it's not that simple, but probably with ddlog, you probably don't have that control. That is my understanding, but maybe I'm wrong.
Yeah, with ddlog, we don't. I mean, we did do like, I mean, I'm not going to take credit. Like Leonid, I did write a bunch of tests. We did find some bottlenecks in ddlog initially. Leonid did do a lot of work to optimize the ddlog implementation. I think that the optimization we make are more like generic in ddlog and kind of like benefit all use cases, unlike what we could do in Golang. But like a lot of optimization work did go ddlog implementation as well. It wasn't like if Leonid wasn't here to help, I mean, it would have been like definitely tricky for me to do the same thing.
But what I mean that these are more generic optimizing, as you said, right? I mean, sometimes if you need to make some trade-off, like sometimes you just want to optimize specific piece. But for some other corner case, you are saying, okay, for some reason, maybe you don't want to increase memory or whatever. You don't want to optimize. And I guess with ddlog, probably you cannot do that fine-grained control.
No, yeah, that's probably true.
Thinking kind of in the future, the question I have is, can we take the model that ddlog is building? There's some really interesting papers on Tyros and Zelkova that AWS had built that used satisfiability solvers, and I think Datalog was one of those. They basically used the information to construct horn clauses and basically check reachability queries. That might be another interesting application when we want to extend, visibility on what nodes are reachable from like a provable security perspective. So already having the underlying model from something like ddlog could prove useful.
Yeah, I believe that kind of query could be added like very easily right now. Yeah, and I guess the last point is it would be a bit more difficult from a toolchain perspective and not really a distribution perspective, more like a toolchain perspective to adopt something like ddlog. There is like an extra step in compilation when you actually modify the ddlog logic. I think this is not very significant because everything is containerized pretty much. So actually putting in ddlog into the toolchain wouldn't be very complex. And once it's in the final Antrea Docker image that we distribute, there is no like significant difference. It's just an extra .so which is included in the Docker image. So I think from a toolchain and distribution perspective, a bit harder with ddlog, but not significantly harder. So I'm not expecting to come to a decision today. I'm gonna send the slides to everyone. So if you want to look at it, feel free to look at it. I want to send Chan as well. Send him the recording of the meeting. See what he thinks, if he has any opinion on this. And if you have any test benchmarks that you'd like to suggest of a representative use case scenario, feel free to share it with me. I'm happy to add a new test if you're interested.
Looking forward to review the slides and your POC code and the DDLog code. All right, thanks a lot, Antonin. Is there any question?
I just have one comment here. I think at least we can evaluate how much more complex it can be if once we introduce this policy tiering, and some more criteria like matching a condition, whatever, and then if it's really much more complex, then.
One thing to think about policy tiering, though, is I think it's probably going to be similar. We're just layering policies, and really the tiering aspect is going to be a runtime evaluation, right?
Actually, for controller, I guess probably doesn't really impact much the complexity. For agent, it will definitely be more complicated. But anyway, we are not talking about DDLog for agent yet.
Right.
Oh, because my understanding was more that we would handle all that complexity in the controller, and that actually the outputs that we send to the agents, because they're already in terms of like IP addresses. I thought
flows.
That is true, but I'm saying agent is more complex because now you have multiple tiers and you can have delay rules. You also have priority of rules. Then you have to assign priority to this rule, to this OS flows, and you have some limit on this OS flow priority values. I think it's like 16 bits or something. So there's some complexity around here to dynamically allocate and adjust the priorities, something like that.
I think it may be a good idea for, I'm going to send the slides, let everyone digest that, and send them to Abhishek and Chan as well. But maybe we can have a meeting with them early next week or something, where we can discuss the impact of like tier network policies on the controller implementation.
I think it's like we, go ahead.
So one other question is are we building the current engines that we have, are we isolated enough where if we decide to switch this in and use DDLog later, like we're not incurring so much technical debt over the next several months, that we could still make that change relatively easily? Or is there things we need to do today to make it easy to make the switch later?
The switch is very easy because we just update the store in the same way as we do today. That's why it was like so easy to compare the two. The only thing is if we add a bunch of different features to the controller, but I don't see that happening in the immediate futures. And I mean, obviously we need to update the DDLog program. I don't think switching itself is going to be a big cost. And I don't see like, obviously if we start implementing like tiering, network policy tiering, then that's a big change. It's not going to fundamentally change how we integrate. It's just that we need to update the translation code and the DDLog logic itself.
That makes
sense. Switching is fun, but just like if you want to go DDLog, it seems it's a long-term investment. I mean, you see Anthony is doing his Golang binding. If you sure. Chain and integrate into our view, right? So.
Well, that's done. That's not going to change. So that's not more effort on my side. I did that already. Sure. It was my way of paying back Leonid for writing the DDLog code for us for Antrea. So.
Sure. I just mean, since we need to have a long-term commitment to this language, so we can decide to invest.
Yeah, definitely. There are some things which are expensive to do that we would only do. I think maybe that's what you were referring to. Like we can improve the Golang bindings and the data passing, but that's kind of like a big cost. So
right.
One more thing to add. Actually, I believe Weimar decided to use DDLog a lot in NST control plan. I think that's already a decision made. Of course, it's Java, but maybe
I think
the
upside of DDLog increases with the complexity of the controller. So it's really about that.
That's true. That's true. I think for NST, it probably makes more sense. Really lots of features there.
So it's really about what kind of features we expect in the future. it's hard to predict the future.
Yep, and but I can talk about the present, and we are at time for today. So I think that I mean I was curious about what's the behavior of DDLog compared to the current implementation in presence of failures, but maybe we can discuss that offline on Slack, you know, or maybe it could be another test case to define, simulate injecting a fault in the controller, and then I guess that see whether DDLog performance is comparable or not with the native performance. But that's a story for another meeting. That's a discussion for another meeting, because unfortunately for today, time's up. And I would like to thank you everyone, unless you want to bring up some very last topic. Going 5, 4, 3, 2, 1, 0. And therefore, with this, we conclude today's meeting. Today is obviously April 8, 2020. Thanks everyone for attending, and we'll meet again with a new meeting time on Monday, April 21st, 9 p.m. Pacific time, or 6 a.m. Central European time on Tuesday, or 12 p.m. Tuesday, April 21st, China time. All right, thank you very much for attending, and have a good one.
Thank you.
Thanks.
Bye.